All right, let's get started. Welcome everyone to ForeFlight's integrated and automated solution for Bombardier operators. In this webinar, we've partnered with a couple members of Bombardier's team to go over how ForeFlight runway analysis and the more recent ForeFlight weight and balance can help you complete your flight planning and flying in Bombardier aircraft and really speed up and make your operations more efficient overall. So from the ForeFlight team, we'll just run down each one of these. First up, we've got Josh Pava. Josh, do you want to go ahead and introduce yourself?
Thanks, Sam. My name is Josh Pava, and I work for ForeFlight in QA, primarily on ForeFlight dispatch, as well as runway analysis and weight and balance. In addition, I also fly and manage the Bombardier Challenger 650 that you're going to be seeing me use today in our demonstration. Alex, over to you.
Thanks, Josh. And my name is Alex Smithers. I am ForeFlight's Director of Business Development. Throughout the year, this year and last year, I've worked with Bombardier and a number of airframe OEMs on developing the relationships to procure the performance data and the performance data licenses that we are utilizing for our flight planning, runway analysis, and weight and balance solutions. I'll turn it over to Michael.
Thanks, Alex. My name is Michael Vogt. I'm an aircraft performance engineer, have been for some time, and I've been with ForeFlight since 2015. Kind of knee deep in weight and balance and runway performance, and as well as flight plan performance involvement in terms of how that goes. Reiner, over to you.
Yeah, I'm Reiner Howe. I'm a customer liaison pilot with Bombardier for the last 11 years, mostly on the Global Express and Global 7500 series. I've also had a lot of experience on Challenger 600, 604s, and I'm involved, my prime role being customers' operational issues associated with Global Expresses. Over to you, Eric.
And I'm Eric Boucher, so I also work at Bombardier, specifically in the digital partnerships development and strategy team within digital innovations. So I'm responsible for engaging with third parties like ForeFlight and making sure that they have access to all the right data at the right times.
All right, thanks everyone. So our topics for today are going to start with an overview of the collaboration between ForeFlight and Bombardier, and specifically how Bombardier engineers have provided the ForeFlight team with all of the data on their aircraft that we need in order to construct these runway analysis profiles and the weight and balance templates. Next up, we'll be walking through a live demo of the integrated workflow, both from creating the aircraft profiles, setting up those weight and balance profiles, including with basic operating weight setup. And then after that, we'll move on to actually planning a flight using the integrated weight and balance, and then moving on finally to runway analysis planning as part of that same flight plan. So this is pretty much going to be a start to finish demonstration of how you can get the aircraft set up and then actually plan these flights using these new capabilities. And then finally, we'll have a quick wrap up and Q&A at the end. So just a couple items before we get started. You can ask any questions you have via the GoToWebinar message panel on the right. Just click that button that looks like a question mark inside a speech bubble, and you can type in your questions. Our team members will be responding to them throughout the webinar, and we will be answering some of them live during Q&A at the very end, but we strongly recommend that you submit your questions whenever you think of them. If you wait until the very end when we start Q&A to submit a question, it's probably not going to be answered. So definitely consider submitting your questions as soon as you think of them. We also strongly recommend that you join from a computer and not a mobile device. We just find that GoToWebinar performs a bit more smoothly on a computer, and mobile devices tend to have more audio problems. So again, if a computer is available, we strongly recommend you join from that. And finally, the session is being recorded, and you will be able to watch it starting tomorrow at foreflight.com/webinars, which is where you can also find recordings of all of our previous webinars. So with that, I will hand it over to Alex to kick us off.
All right, thanks, Sam. And I'm going to go ahead and start with an introduction of both our runway analysis solution and weight and balance. So new in 2021, we at ForeFlight released a takeoff and landing runway analysis solution for business jets, which we built from the ground up. Having our own proprietary engine has given us tremendous flexibility in our implementation, which has allowed us to tightly integrate the runway analysis solution, as well as weight and balance into the flight planning, user interface, and And the great thing about that is that as you're updating passengers and cargo and fuel parameters and other things for your flight plan, we're automatically passing that information into the runway analysis, takeoff and landing calculations, and the integrated weight and balance. This is really great. And you'll notice that as you're making changes in one part of the flight plan, we're automatically rerunning calculations and presenting updated performance results and highlighting any errors or warnings that need remediation. We are, of course, also automatically pulling in forecast or actual weather conditions based on the time of departure and arrival. So flight planning a week in advance may use our 10-day forecast weather and then transition to TAF or MOS within a day or two, and finally to the latest METARs for the departure, arrival, or nearby airports. You can, of course, manually input weather conditions, for example, when you're recomputing for arrival or even plan using zero winds. We also have a runway analysis solution tightly integrated into our dispatch product. ForeFlight is automatically running calculations for multiple runways, which is resulting in our automatically suggesting the best possible maximum takeoff or landing weight, runway, and engine out procedure where applicable. And the third point here is that we've signed an agreement with Bombardier to get our aircraft performance data directly from the source, so you can have full confidence in our solution. We'll talk more about that, and as well as the available aircraft and the performance data here in just a minute. Finally, we've created our own tech for designing engine out procedures, which you'll see here in just a little while, which has helped us to build over 6,000 of our own procedures at this point, with more coming all the time. With that, we cover the lion's share of airports used by business jets internationally, especially those that are in mountainous terrain. This results in our ability to suggest the highest possible maximum takeoff weight depending on the limitations imposed by the surrounding terrain and obstacles. You'll see later too that a description of the engine out procedures, the instructions is included in the takeoff view along with a visual representation on the map. We also launched our integrated weight and balance for business performance customers just prior to the NBAA base conference this year. It's worth noting, because we'll get some questions about it, that the integrated weight and balance will be made available for customers on individual accounts in the coming months. As the integrated weight and balance implies, we've introduced the ability to configure weight and balance profiles for your business jet aircraft, and the ability to input specific load, weights, and seat or station assignments as a part of your flight planning process in the Flights tab of ForeFlight. You'll see in this graphic here that we also have weight and balance available in our dispatch application, which is available for integration with your scheduling system, meaning that your basic load details that your scheduling vendor may be sending us with your scheduled flight data will automatically be assigned to the default seats or stations to further reduce the number of manual inputs you need to make in dispatch or in ForeFlight Mobile. Josh will demonstrate both the runway analysis and weight and balance capabilities here in just a few minutes. We understood pretty early on that we could automate much of the takeoff and landing and weight and balance calculations by leveraging the weather and other data that you guys are already putting into ForeFlight during your flight planning process. With this simplified process and easy to use UI, our hope is that our solution empowers more pilots to understand the limitations of their aircraft and improve the likelihood of a safe outcome for every takeoff and landing. With this addition, we have a fully integrated and cross-checking solution in one app you can run on your iPhone, iPad, or web browser via ForeFlight Dispatch today. Regardless of your choice of platform, you have full flexibility, whether you're planning your flight in the office or updating your plane numbers on your iPhone due to last-minute payload changes. You're also free to choose your workflow, i.e. maybe you prefer to do weight and balance before runway analysis or the other way around. It's really easy to kind of pick and choose the way that you would like to operate, since it's all integrated there in one easy to use application. And with that, I will turn it over to Eric.
Thanks, Alex. So the key message here that I want to share with everybody is that ForeFlight is getting accurate, up-to-date information from technical publications directly from Bombardier. And they are authorized to use all of our tech pubs for all models. So that does include things like the AFM Chapter 6 data, the FPCCM, the QRH, among others. The other important point here is that ForeFlight does receive revisions for the duration of the subscription. So as revisions are posted for any other manuals, ForeFlight is getting them and is integrating them into their solution. I'd also like to draw your attention to the graph on the right here. This just goes to show that ForeFlight really is integrating our source data directly into their system. So they're taking the aircraft performance data and adding things like obstacle data, airport data, engine out procedures, performance engine. They're taking the flight planning data and adding their own engine to it, and then adding additional data to it to create an end product that's easy for you to use. I'll hand it back to you, Alex, if you want to go through the next slide.
Thanks, Eric. Today, we cover virtually every Bombardier aircraft, including Learjets and most of the older models for en route performance and flight planning. We've added support for a number of models for takeoff and landing performance and runway analysis since we launched that capability in March of 2021. Today, in November 2021, we support most of the newest Learjet models, the Challenger 300, 604, 605, and 650, and the Global Express 5000 XRS and 6000. We tend to introduce support for integrated weight and balance at the same time as we introduce support for runway analysis. We also offer support for mixed fleet operators and are adding support for new aircraft in every release. So with that, keep an eye on forflight.com/RWA, where you can always find the most up-to-date list of current aircraft support for runway analysis, along with links to our webinars, our frequently asked questions, and more information about this suite of tools. And with that, over to you, Josh.
Thanks, Alex. So today we're going to do a walkthrough of a flight between Eagle and the Hamptons in a Challenger 650 using ForeFlight Mobile. We're going to cover a few areas of aircraft setup, en-route planning, weight and balance, and runway analysis. On our screen, you can see our general route, which is leaving the mountains of Colorado and going to a fairly short runway in New York. So behind the scenes of our flight planning engine, as well as the app's flight planning powers, we have accurate, high-fidelity in-flight aircraft performance models using OEM flight planning performance data. And what that basically means to us as ForeFlight users is we're using OEM source data to come up with performance for the aircraft, performance for the flight that you could replicate using an AFM if you went through those steps. We offer Challenger, Learjet, as well as Global Series flight planning data. And we newly support climb, cruise, and descent biases. So what that means, if you want to add 3 minutes and say 300 pounds to your climb, you're able to do that. For cruise, you're able to add or subtract a percentage bias, similar for descent. Global flight planning and filing capability is something that I've happened to use quite a lot in ForeFlight Mobile. Essentially what that means is for worldwide, you are able to flight plan as well as, for the most part, file anywhere in the world. One thing that some countries require is an ICAO document to be handed to the flight planning office, and that's something that we support as well. The routing that we offer is wind optimized, ATC cleared routes, and as well as performance optimized. So essentially what that will give us as pilots is a route that is based on the best winds with the highest probability of being cleared as filed, and as well as it's optimized for the aircraft performance. So we can step climb, set an initial cruise altitude or a final cruise altitude or a max flight level for the cruising. Pretty powerful flight planning options that we have that enable us to essentially flight plan for exactly how we want to fly the flight. Within ForeFlight Dispatch, we offer ETP and ETOPS diversions, which will also go into ForeFlight Mobile once released. So, if you're going oceanic, you're able to plan your ETP airports for the common ETPs of depressurization, engine and operative, as well as a medical depressurization. And most importantly, we're always improving the flight planning engine. So what you see today is certainly not what's going to be the capabilities in a year from now. It's constantly improving, and we're constantly seeking feedback for what your needs are. So now we'll get started with aircraft setup. And the way we set up an aircraft in ForeFlight Mobile is we go to the More menu in the bottom right-hand corner. And from there, we choose aircraft. In my current view, it's the third one down. However, that could vary on yours depending how you have ForeFlight Mobile set up. For what we're going to do today, we'll be using the Challenger 650. So we'll go ahead and under tail number where it has the orange writing. So we'll go ahead and put CL 650 as our tail number. We can skip the serial number for the moment, and then we'll go on to aircraft type. So I've clicked the aircraft type, and I can type CL60, or I could type Challenger 650, and that will pull it up as well. So as you can see with the various challengers we have listed here, we have 7 performance profiles that are made by ForeFlight for the Challenger 650. And what that means is basically that's your climb, your cruise, and your descent performance profiles. And we'll go into those here in just a minute. We can also see if the Challenger 650 supports runway analysis, and it also has a weight and balance template available. So we'll go ahead and click on the Challenger 650. And from there, we have some categories here that are fairly self-explanatory. Aircraft category, the color of the aircraft, home airport, airspeed units, length units, etc. For the purpose of what we're discussing today, the performance section is quite applicable. So we'll go ahead and click the performance profiles selection. So when we click there, we're then given the various models and the speeds that we have modeled. So in this case, we've modeled for the Challenger 650. We have 250 knots to 300 and transition to 7.8 in the climb. For cruise, we have various speed selections that we can choose. For today, I'm going to go ahead and choose 300 knots, Mach decimal 80. If I had any desire to bias the cruise fuel flow, I can do that from this screen by using the slider one way or the other. In this case, I'll operate with a 0 bias, and I'll go ahead and make that the default. Similar to the climb, we have a descent profile, which again comes right out of the, in the Challenger's case, the FPCCM, AFM, and it's Mach decimal 7.8 to 300, transition to 250 knots. For some aircraft, we have multiple climb profiles and multiple descent profiles available. For others, there may be just one. Continuing under performance, as I click the back button, we have runway profile. Again, some aircraft may have more than one runway profile available in this screen. In the case of the Challenger 650, it is just one. It basically covers all the serial numbers. And under the field performance selection, we have a number of defaults. So under takeoff, we have NAICE, APR, 10-stage bleeds, etc. I like to think of these as how am I going to configure my aircraft on a normal takeoff. So normally I'm going to have NAICE off, I'm going to have APR armed, 10-stage bleeds for me are going to be closed. I'll be on the APU, 2 operative thrust reversers. One, I operate out of a fairly short runway, so I typically operate with rolling takeoff set to no. So to change that, anything that's blue is clickable. So I've just clicked on the rolling takeoff line, and that's going to allow me to make a change there. In this one, it's a pretty simple change. We just simply say, no, we're not going to plan a rolling takeoff. And there's some other options here that are a little bit less common. One thing for our non-US operators that may be interesting is the obstacle corridor. We have the FAA corridor as well as the ICAO corridor. Essentially what the FAA corridor is it's pursuant to AC 120-91A. The ICAO guidance is a little bit of a wider corridor and some other miscellaneous changes. So if you're N registered, chances are pretty good you're going to be on FAA obstacle corridor. If you're non-N registered, you probably are likely to be using ICAO. While we're here on this page, we can transition into the landing defaults as well. I won't go into them in particular, but you can see we support options like the landing flaps, whether you're going to be incrementing your VREF, whether NAICE will be on or off, your 10-stage bleed status, etc. And in the case of RCC for the Challengers, we also support an anti-skid selection as well as ground spoiler selection. Finally, I think applicable to most of us watching this webinar is that the last item under landing is the landing factor, and currently set to 1.0. However, there are some various presets that we can select. In this case, we'll go ahead and choose 1.15 just for the purpose of demo. And lastly, on the very bottom line, you can see our AFM revision. So in this case, we're using AFM revision level 23 for the takeoff and landing data. Go ahead and go back using the upper left-hand arrow. And so essentially at this point, we have set up our performance profile, our takeoff and landing defaults, and of course the runway profile, which in the Challenger 650 is only one that's able to be chosen. If you had to set up or you want to set up some glide performance, that can be set up here. If you do that, that will allow you to show a glide range ring on the map view. It's outside the scope of this webinar, but it is available if it's something that you're interested in. Under altitudes, we have the max ceiling for the aircraft as well as the default cruise altitude. We'll go ahead and choose the default cruise altitude to be 37,000 feet for this aircraft. And finally, we have our weights. So as an operator, we can choose whether we're going to be using pounds or kilograms. For today, we'll leave it in pounds. Most of this data is pre-filled for you based on the aircraft profile. So the max zero fuel weight, ramp weight, takeoff weight, and max landing weight are probably going to be the same as what your aircraft is for the Challenger 650. However, the basic empty weight is something that you'll probably need to change because, of course, that's airplane specific. For today's demo, we'll do a basic empty weight of 26,362. That's modeled after the aircraft that I fly. So it's a realistic weight for at least some of the aircraft. And moving on to weight and balance, we have an option here, add weight and balance profile, which we'll go ahead and click that. When we do that, we're presented with a couple pre-filled templates. In this case, we have a 12-passenger configuration and a 10-passenger configuration, and that's coming right out of the weight and balance handbook for the airplane. So it's likely to closely match the configuration of the aircraft that you might be flying. And lastly, if we wanted to start with a completely blank template, so no seats, no galley, no lavatory, no baggage, etc., stations, we could start with a blank template. In this case, we're going to go ahead and use the 10-passenger configuration.
If you had a particular configuration that you would like to use, you can set them up and keep them in memory and select them as required. Isn't that correct?
Yeah, I mean, you might start with a 10 or 12 passenger. You might start with a blank. I think theoretically, you're going to start with either a 10 or 12 and modify from there, rather than blank, which has basically nothing.
So basically what you can do is customize for various types of missions that your operator might wish you to do.
Yeah, that's right. There's 2 orange items like we saw on the previous screen, which means that as the individual that is setting up these profiles, I need to input something here because we don't have the data. So for this aircraft that we're setting up, I'm going to use a CG of 524.24 inches. And I'm going to set my basic empty weight on this screen to be 26,362. When I'm done with that, I click the close button, and then we can see below we have various stations that are pre-filled. So in this case, we have items such as tow bar head, the tow bar, the flight deck seats, manual storage, etc. For the purpose of this demonstration, I'm going to show what happens when we click the tow bar head. We're brought to another page that is very similar to all the items if we click on, in that it allows us essentially for configuration. So the name tow bar head, that's pretty descriptive, so I'm going to leave it with that. Again, this profile has pre-filled in the arm for where the tow bar head is as 185.6 inches. And I have this option right below there, include in BOW. So just as it sounds like, that's a toggle that allows us to either include or exclude an item from BOW. In my case, I always carry the tow bar head with me. So I'm going to say include in BOW. That then allows me to specify a weight for this item. I'm going to say the tow bar head weighs 16 pounds. I'm going to close out. And if there was a weight limit, I could specify it in the line below. And lastly, we have a notes section. And that notes section could be handy if you want to note something specific, like we only include this item if we are flying internationally or something along those lines. So now that the tow bar head setting has been configured, I'm going to click the back button. And we could continue to do so all the way down. I'm going to configure a BOW for the flight deck, since again, I think that's a pretty common thing that we all would probably want to do in many cases. So in the flight deck, I'm not going to change the row arm or the row weight limit. I'm going to leave those as they are. And below that, we have the seats in that row. So considering we're talking the flight deck, we have two seats. We have pilot and co-pilot. So I'm going to click the pilot line. And just as we saw on the previous screen, I'll include that in BOW. I'm going to put the 180 pounds as the weight for the left seat pilot. We have a weight limit of 380 pounds, so we're well within that limit, although we will be warned when we compute weight and balance if we've exceeded the limit. Now that I have selected BOW, just like other stations as well, the pilot has a BOW gray tag, which tells me quickly that that station is included in BOW. I'm going to do exactly the same thing for our co-pilot. And I'm going to continue back to our weight and balance setup screen. So we can now see the tow bar head and the flight deck are BOW stations. From here, we can see the various other stations that are possible, but in the interest of time, we're going to back out of here. But before doing so, the Challenger is a %MAC airplane. And so I'm going to select the toggle on the bottom of the screen that converts this aircraft to use %MAC. Again, it's a simple toggle on and off. And once I've set that toggle to on, the values that I receive from weight and balance are going to be in %MAC. I guess one additional thing, if operators are using a curtailed envelope for their CG, this is where we would add that curtailment. We, meaning ForeFlight, we only provide the data that the AFM provides, meaning the forward and aft limits at the various weights. However, if an operator wants to customize that for whatever reason, they could either add an additional limit or click anywhere at one of the weights or the CG range and change that from there. Michael, Reiner, do you have anything to add before we move out of this screen?
It's Reiner. You won't see this on Challengers, but you will see it on Global Expresses that work with curtailed envelopes. But that stuff is very clearly outlined in the weight and balance sheets and so on. It should be easy to transfer to this configuration here.
As we back to the aircraft profile configuration page, we have some other options that are fairly self-explanatory at this stage of what kind of fuel is the aircraft using? Are you using for fuel units? Are you using pounds, gallons, liters, kilograms? Other configuration that I tend to do is a start, taxi, and takeoff fuel. I find that's pretty operator specific. So if you're an operator that runs the APU a lot, or perhaps you do long taxis, you might want to just click on that 300 in blue, change it to something like 400. And now for every flight that's created moving forward, your taxi fuel is going to be set at 400 pounds. Total usable fuel is, per the aircraft. Some people may want to reduce that if they say, hey, my aircraft never carries, 20,000 pounds to carry 19,700. You could change that there if you wanted to. Reserve policy we'll talk about in just a little while. And default reserve fuel, we'll go ahead and change that to something like 3,000 pounds. Filing is outside the scope of this webinar. However, if you wanted to configure your filing equipment, you could do that here, both if it's an FAA equipment, ICAO equipment, ICAO surveillance, wake turbulence, PBN capabilities, etc. Any life rafts and not like, it can be set up on the aircraft profile under the dinghies as well as the emergency section. And if you are interested in NAV Canada filing, you specify your undercarriage and your type of ELT on the bottom portion of that page. So that concludes the aircraft profile setup of our Challenger 650. So we'll be moving on now to en route planning. So moving on to en route planning, the way that we get into a planning mode is one of two ways. We can do it from our Maps tab or our Flights tab. Either workflow is perfectly acceptable, and in the end, they sort of meet at the same place. I tend to start from the flights tab, and the way that I would create this flight that we're going to go on today is pressing the plus sign on the upper left-hand side of the screen. And that creates a new flight for us. First thing we need to do is set departure time and date. So we'll just say that the flight's going to depart today at 2 p.m. Our departure point we set by pressing the line that is labeled departure, and that gives us an airport selector. We'll go ahead and type in KEGE for Eagle with our destination KHTO for East Hampton, New York. That leaves us with a blank alternate line. And what we'll do is we'll press the alternate line, which will give us our alternate advisor. It's going to suggest a few possible alternates for us. Once that populates, we're going to decide which alternate that we want. For me, I can see our very first suggested alternate is Islip. Winds look pretty good at 270 at 9. It's a VFR airport. It's indicated by the TAF with good visibility. It's towered with a runway a little over 7,000 feet. I can see it's going to take about 6 minutes and burn a few hundred pounds of fuel to get there. So I'll select Islip and press the Add Islip as alternate button. Aircraft has been pre-configured with the ICAO codes and PBN and what have you, as we saw on the aircraft configuration page. So we won't change anything there. We'll just leave it as is. And for the performance profile, we set our defaults like we discussed. But if we wanted to review those or change those on a per flight basis, we can do so by simply pressing the profile line and making any changes here. So as a review, we've selected the climb profile of 250 knots to 300 knots to Mach 0.78. And then the cruise profile of 300 knots to Mach 0.80 with a descent of Mach 0.78 to 300 knots, 250 knots. So we'll accept those by just pressing the back button. Of course, we're going to be doing this flight IFR. And for our route, currently it's a blank route field. However, when we press the routes button, we can see there's 10 options. And it takes just a moment to populate those 10 options. And we have a couple choices here as far as under each category. So we have our recommended route, which I briefly covered earlier. The recommended route is ATC optimized, performance optimized, and has a high probability of being cleared as filed. In addition, there are ATC cleared routes. So these are the cleared routes between those two city pairs. And for the purpose of today, I'm going to go ahead and choose the recommended route. In some cases, there may be a third or even a fourth if there is a preferred route or some such thing. However, the recommended route I can see is 3 hours and 37 minutes with a fuel burn of 7,840 pounds, quite similar to the ATC cleared routes. And knowing that it's an optimized route, I feel pretty confident about choosing that route. So I simply select it by pressing on it and choose select route. And now it's asking me if I want to change my altitude to flight level 410, given the route and the length. I'm going to choose update to flight level 410. And now along the top bar, we can see essentially some data that it never moves, even when we scroll. So that data says the distance of 1,699 nautical miles. It's going to take 3 hours and 37 minutes with our arrival time of 7:01 p.m. Flight fuel of 7,840 pounds with a 19-knot tailwind. As we continue scrolling down, we've already selected our cruise altitude as 41,000 feet automatically, and we can move on down to our payload section. We can select in a couple ways how many people we have on board, how much cargo and total payload, or we can press the weight and balance button from here and go into a more detailed view. So when I do that, that takes me into the page that we're seeing right here. And I have an option towards the top that says weight and balance profile. So I can click that and I see any profiles that I have configured for this aircraft. So if you operate with several configurations, in this area is where you would choose the configuration that you're operating in. Today, we only have just one, so it's quite simple. So under seats, we have a few options which are already grayed out. And like we talked about in the previous configuration, the BOW BOW items can be set on an individual basis. So what I've done here is I have the pilot, co-pilot, and jump seat as part of my BOW. In other words, I cannot edit those from this view because they're actually part of the aircraft weight and balance profile. However, I do have some seats shown in blue, which can be edited. So we'll add a few passengers here. We'll put them in seat number 4, and we have some standard weights that we can use. And so we'll go ahead and add a male as for standard weight in the right seat number 4. For the left seat, I'm going to add someone that's 160 pounds, and I'm just going to call them a passenger. That's going to allow me to quickly use that passenger on future flights without having to re-enter their specific weights. I'll put a passenger on the divan as well, and we can see on the bottom of this screen, we have a save load section now. So that's what we just created, the passenger of 160 pounds as a save load. However, what we're doing here, we'll go ahead and just simply add a child on that seat. We'll continue scrolling down into the other areas that we can configure. For cargo, we'll say we have 250 pounds of cargo. Aircraft items for my aircraft are pretty much exclusively BOW items. So I'm not really going to do anything with those other than perhaps verify that they're correct. One option that I have if I don't want to see the aircraft items list, and this is true for each configuration, is from the flights view, I can collapse those aircraft. However, as I create items here, they're not collapsible. Finally, for fuel, we have computed already that how much fuel that we need to do this flight. And so for fuel, we've already used the preset logic for where the fuel is going to go. So in this flight, which is carrying just under 11,000 pounds of fuel, our main tanks are going to be full. Our auxiliary tanks will have 664 pounds in them, and our tail tanks will have 251 pounds. We're now going to click the back button that's labeled Eagle to Hamptons, and we'll continue now with our in-route setup and weight and balance setup. So like we talked about, once we're on this screen, we can see what all of our weights are for each of the stations. And if I don't want to see that whole area, I can simply press the arrow and collapse or expose each section. So this is the section that we have where we can view it quite verbose or in a compact way. Perhaps most important is once I am out of that screen, I have a green imbalance. So quickly I can see on the weight and balance line, it says that I'm in balance, which means that this flight is able to depart and stay within its CG. If I want to see specifics of the CG, I can do that from the summary page, which we'll get into a little bit later, but we can see on the lower left-hand corner at our BOW, our zero fuel weight, our ramp weight, our takeoff weight, and landing weight, what each of those weights are, what the limit weight is, as well as what the CG is. Next section of our flight setup, we have a fuel section. Within the fuel section, we have several fuel policies that we can select. We can see that at the moment, we have minimum fuel required selected. However, if I press on that minimum fuel required, I have several other options, such as extra fuel, which is quite literally just setting how much extra fuel I want to carry on the flight. The maximum fuel, which will say what is the absolute most fuel I can carry and still meet all the requirements to be able to depart from the airport as well as able to land and be under max landing weight. Landing fuel, something that I use quite a bit is, say I want to land with 4,000 pounds. So from this area, I can choose landing fuel, and that will send me back to the flights page. Or I could say a manual fuel as a manual fuel policy, meaning I know I want to carry 15,000 pounds on today's flight. And so regardless of any minutes or maximum weights, et cetera, I can just say carry this amount of fuel regardless. And as I scroll down through the fuel section, I'm able to see kind of a breakdown of what each point is going to contain as far as fuel. So total starting fuel 10,635 pounds. Again, we get a view of where all that fuel is located. The flight fuel is just shy of 8,000 pounds, which that consists of the fuel to destination plus the taxi fuel. Fuel at landing, in this case, is 2,669 pounds. If we want to increase that to say 4,000 for our landing fuel policy, we can do that. And that's going to change the fuel policy towards the top. And now it says landing fuel policy. And that allows us to see a breakdown of 800 pounds to the alternate, our reserve fuel being 1,875 pounds, a totaling of 1,325 pounds extra. Below that, we have the weight section. Not a whole lot to talk about here, other than it's a great summary of everything that you just set up. And so essentially what that is showing me is what's my zero fuel weight, what's my ramp weight, takeoff weight, and landing weight. And for each of those, under that text, we have some gray text that will show how many pounds you have available from the maximum. So in the case of zero fuel weight, I weigh 28,074 pounds, which is 3,926 pounds from my zero fuel weight 32,000 pound maximum. Below that, we have destination services, which is not something that we're going to go into today, but essentially allows us to set an FBO, which will be printed on our Navilog, as well as submit a fuel order or fuel release through Jet Fuel X or one of the contract fuel providers. Flight log is something that can be used at the conclusion of the flight, which allows me to notate the fuel at shutdown as well as the times. So time in, time out, time off, and time on, as well as the flight and block time. So now that we've completed our en route configuration for the flight between Eagle and the Hamptons, and we've looked at our weight and balance briefly, let's take a peek at runway analysis. As probably most of us are familiar with, Eagle is a mountainous airport in Colorado, and it's an airport that, by simply using AFM data is going to be a real struggle to depart from and have enough range to get anywhere too distant. So the way that I begin this is next to the departure airport that I've specified, I have two buttons, takeoff and info. I press the takeoff button, which does a brief calculation and tells me right away, your takeoff is impossible due to obstacles. In this case, it's not surprising. We haven't really done any setup, but it's a good indication that this is a performance challenged airport. So we're going to continue on this page, setting up the exact parameters for our flight, which we hope will allow us to find a weight that we're going to be able to depart from to get to the Hamptons without stopping. So right away, I see the runway selected is runway 25 with an 8-knot headwind, 3-knot crosswind. If I press on that runway, I'm able to see a few more details of it. I can see 9,000 by 150. It's an asphalt. I can see the slope. If I press the details button, I'm able to see even more information, such as a glide slope indicator, if there's a displaced threshold, the exact heading, lighting, elevations, as well as the procedures that are applicable to that runway. So I'm going to go ahead and click back from here, having viewed runway 25's data. And I'm going to click back one more time, being happy to be departing on runway 25, or at least that's my hope. Usable length, if I want to change that, I certainly can. I would just click on the 9,000 and make a change. However, I'm not going to do that today, so I'm going to go ahead and close out that view. And for lineup allowance, some operators like to allow 100 feet, 200 feet for various reasons. Reiner, do you have any suggestions on lineup allowances for the Bombardier aircraft?
Well, one of the, we sometimes use a 100-foot default. The reason is that you're never ever, or most cases, not able to get your mains right on the edge of the runway. So you have to have some room to line up, and we encourage the maximum use. For some reason, if you needed a bigger allowance, you could put it in, but to get your reasonable numbers or something that's relatively appropriate, we would suggest using something like 100 feet.
Okay, that sounds good to me. So, for this demo, I'm going to go ahead and take Reiner's suggestion, and we'll put 100 feet for the lineup allowance. The slope is already pre-filled. I'm not going to change it. But if I wanted to, I certainly can do so. Surface condition, of course, one of the important things that we need to set for every takeoff is what's the condition of the surface. Again, these come straight out of the publications from the manufacturer. In this aircraft, we have the dry, wet, compacted snow, as well as a few other ones for slush and standing water, as well as ice. For today, we'll go ahead and leave it as a dry runway. And obstacle analysis, I want to make sure that that obstacle analysis toggle is on as it currently is, because that's asking ForeFlight Mobile to make these computations considering the terrain and obstacles. Engine out procedure is a very important line, probably the most important line of this entire setup is how am I actually going to depart out of Eagle? So I have two options when I click that. I have straight out, which I can see is going to give me a maximum takeoff weight of 35,529 pounds, or I have what we call EOP1, which we can see is an RNAV departure that's allowing a maximum takeoff weight of 40,304 pounds. That's a 5,000 pound or nearly 5,000 pound increase. So we'll take it. However, as a pilot, I want to know what do I need to do to be able to use that 40,304 pound maximum takeoff weight. Is it a procedure that I'm comfortable flying? Is it a procedure I'm not comfortable flying? So once I've selected EOP1, we visualize that procedure. We illustrate it on the map, and I can see what I'm doing. As well, we have it in text format. So the notes that I see below EOP1 tell me it's an RNAV procedure, GPS is required, and unless otherwise specified, all fixes are fly-by fixes, and all turns are climbing 15 degrees a bank. So my first instruction is maintain runway heading, and I'm going to is maintain runway heading until the departure end of the runway, then turn left to Copper. So I make that left turn, I fly a track of 263 degrees to Hines, then from there, 308-degree track to Beaver, then on track 003 to Apris, and I'm going to be climbing in the holding pattern at Apris with right turns, 25-degree bank, 5 nautical mile legs, 002 course inbound, and do not exceed 205 knots. So for those that are familiar with the Eagle Airport, you probably recognize many of these fixes, and they are on the Beaver 1 departure out of Eagle. So when we design engine out procedures, we try very hard to mirror ATC procedures that you're actually going to be hopefully cleared, so that if you do have to transition on to the EOP, you're able to do that fairly seamlessly without having to switch flight plans and do that sort of thing at a time where you're already quite busy. Reiner, do you have anything you want to say on that topic?
No, I think you're absolutely right. If you have the opportunity to use what's already programmed in your FMS, then that makes life a lot easier. And all you have to do then is confirm that the routings are correct. If there are any minor changes that you do to accommodate the special departure procedure, then you can do it at that time. But it makes life a lot easier.
Yeah, I certainly agree with that. So like I said, that's exactly what we've done here. So hopefully that makes everyone's life a little easier if you do have to ever use one of these procedures. So now that we've selected EOP1, I'm going to go ahead and close that out. And any additional departure obstacles is the next option that we have. So if there was a NOTAM that there was a new obstacle, we could manually add an obstacle here that will be taken into consideration for performance planning. And all we really need to know is the distance from the departure end of the runway and the height above the departure end of the runway. So we would simply add an obstacle, and in this column right here, fill in those details. So weather is our next field that we need to fill out. And the weather data is pretty much filled out for us if we're in the near term compared to when our departure time is. So in this case, we have a wind of 240 at 8 knots with a temperature of 11 degrees and altimeter 3047. As the flight departure time becomes a little bit further out, we will revert to from METAR to TAF to MOS, and very far out is daily weather, which is up to a 10-day window of what the predictions are. As we continue down to aircraft configuration, One of the benefits that I find of ForeFlight Mobile is the fact that this is one solution that is fairly seamless, that goes from the flight configuration to weight and balance to runway analysis. So all of this data that we've previously set up is moved from screen to screen. So we have our takeoff weight pre-filled for us of 39,941 pounds. I'm not going to change that. I'm going to leave the anti-ice off. APR is going to stay armed. 10th stage bleeds closed, etc. And keeping in mind that many of these are the same items that we configured in the aircraft profile. So in this case, they should transfer directly from the aircraft profile to the flight creation page. Beyond that, we have emergency return. This is a pretty useful screen because essentially what it is a landing calculation for your departure airport. It's the one place in the app that we're going to allow you to calculate an overweight landing for an emergency return. So like elsewhere in the app, everything is moved over, our departure runway, wind, weather, etc. Our landing weight is moved over, of course, landing flaps, etc. And then we have our calculations on the bottom of the screen. So we would have our go around N1, our V approach, VREF, landing distance requirements. In this case, it's actual, meaning we're not factoring it. We haven't chosen to factor it. And of course, our approach climb gradient, landing climb gradient, and a quick turn maximum landing weight is not really applicable to an emergency return, but it is applicable on the landing page. So if we were doing a quick turn, we have our maximum weight for that quick turn. I'm gonna click back. And from here, we have our performance section for the takeoff. So we have our takeoff N1, our V speeds, takeoff distance, climb gradient, our level off height, and our VFTO. And finally, on the bottom of the screen, we have our engine out procedure in text format. So we've already seen this when we configured the EOP earlier in, but here's a repeat of exactly what we're going to do. Now that we have configured our takeoff calculations, we're going to back out of the screen and we will configure our landing calculation. So we can see on the top header that our landing weight is 32,075 pounds. We have a dash for actual distance because we haven't yet set the parameters. So we'll go ahead and do that and we'll get some performance calculated. So under runway, we're going to click where it says none. I'm going to look at the options that I have. So I have two runways that are 2,060 feet long. Those aren't going to work for me. But I do have runway 28, which is 42,055 feet long by 100 feet wide. I can see that I'm predicted to have an 8-knot headwind, 2-knot crosswind. So I'll go ahead and select that runway by pressing the circle on the right-hand side. And now I've selected runway 28. Again, similar to the takeoff page, I can change various parameters about the runway. Today, I'm not going to. I'm happy with the landing distance available, 4,255 feet. The slope is what it is. I verified it and it's accurate. We're going to be landing on a dry runway and we're going to set a landing factor. Reiner, what landing factor do you recommend?
Well, normally in normal operations, using 1.67 for typical landing field lengths. Unless you're operating under some other rules, for example, reduced landing distance or reduced required landing distance, which requires you to operate in 80% of the run on 80% of the runway versus the 60% that a 1.67 does. So for default for normal ops, I would assume 1.67 unless you were wet, and then you'd go to 1.92.
That sounds great to me. That certainly matches what I do. And as we can see here, we have a number of defaults that are pre-filled in. For various operators that you might be using. And we also on the bottom of the screen have an option that we've labeled custom. So if none of these preset defaults are applicable to you, you could also say custom and manually enter it. For here, we'll use the custom field, but we will type in 1.67. We do a brief recalculation, and now we can see that the header has updated us to a factor distance of 3,920 feet. We'll continue down with the configuration just to make sure there's nothing else that's going to affect our landing that might change anything. For weather, I'm happy with the predicted 280 degrees at 8 knots, 14 for the temperature with an altimeter of 2983. But of course, both in the planning stage as well as top of descent, we can go in here offline or online and change anything and immediately get new landing numbers. But for planning, I'm happy with what I see. Aircraft configuration, we won't go in too much, but we can see that our landing weight has been moved from the flight to our predicted landing weight. Of course, we're going to be landing flaps 45, no VREF increment. We're not planning any icing. We've transferred air to the APU with 2 operative TRs, no ice accumulation. Our landing gear is not down, and we're not using RCC today, so we can skip that. However, it is a good point to discuss RCC. So Michael, would you like to talk a little bit about that? And maybe Reiner, you can add some commentary?
Yeah, sure. So with the global reporting format rolling out recently, the need for operational landing distances, specifically to handle the runway contaminant codes, RCC values is there. And Bombardier has provided us all the information, in order for us to build those into our models. And we have added the ability to select RCC codes on landing for pretty much all the Bombardier aircraft that we currently support.
Great. Would you like to add anything, Reiner?
Yeah, just be careful, because the data that you have in the QRH for runway condition codes, you have tables for the specific conditions, which is what you should probably be using before the approach to assume that you've got the right landing distances capabilities. If you use the FMS factors tables, be prepared that you might get a pretty high or higher than expected landing distance requirement, because the factors are very conservative. When you're getting to a runway, perhaps like this one, if you wanted to find out more accurately what you want to do, use the specific tables for the RCC code rather than the FMS factor table.
Yeah, thanks, Reiner. That's very great feedback. So now we have essentially set up the parameters for our landing. We can review the performance for our landing. And everything is grayed out here because these are values that ForeFlight is telling you. There's no option to customize anything here because the customization should have happened already. So we get a view of our go around N1, our V approach, VREF, factored landing distance based on the factor we entered a little bit earlier, our approach climb gradient, our landing climb gradient, and again, the quick turn maximum landing weight. Before we leave this page, now that we've configured a takeoff and landing for our departure and destination, and it can be done similarly for alternate. So in the interest of time, we won't go into that. But what we will do is we'll show what we call our summary page. We get into the summary page by clicking the upper right-hand side of the screen, and that presents the form that we're looking at here. Labeled, runway analysis from Eagle to the Hamptons. So we have our takeoff summary, our landing summary. And again, this is all items that we've already discussed previously. So our weather, our aircraft configuration, the obstacle criteria for takeoff, those such things. And of course, we say, how are we going to depart this runway? We already talked about it's EOP1. And so we look at what our TORA, TOTA, and ASDA is, 8,900 for all, dry runway, and our takeoff weight of 39,941 pounds. All those conditions combined give us a takeoff N1, and then it gives us our V speeds, our takeoff distance, and our level off height. Below the takeoff summary, we show the engine out procedure in text format one more time. And then on the right side of the screen, we show our planned landing summary. Again, very similar to what we see on the left side, except this time it's for landing. So everything we've already set up, it tells us our landing weight, 32,075 pounds, our V approach, VREF, our factor distance, our approach climb gradient, and go around N1. As we continue scrolling down the page, we go into a takeoff analysis and landing analysis table, for lack of better words. I think most of us are probably pretty familiar with what this is showing us, but as a review, in the takeoff analysis section, we have both the runways that are possible, runway 07, runway 25. We have the distances available for each of those runways, the slope for each of those runways, and then the wind components on each of those runways. Moving down just a little bit, we have our maximum takeoff weight from each of those runways using various departure procedures. So focusing on the right side of the screen, runway 25, we have two departure procedures that are possible, either EOP1 RNAV or straight out. We can see that if I use EOP1, that I am limited. It says TO thrust time, so takeoff thrust time. So we can see that our limit reason there is because we're going to hit the amount of time that we can have our takeoff thrust set. So it gives us a weight of around 40,300 pounds if we use EOP1. On the other hand, if I don't want to fly the EOP and I just want to do straight out, we can see that we have a limit code of obstacle with a limit weight of around 35,500 pounds. For illustration purposes, we could move to the left and see runway 07 and see we're even further limited. But again, same philosophy applies there. We have three options for takeoff this time, and we can see that takeoff thrust is our limit code for all of those departure procedures. And we do also show essentially a temperature above where it's at, as well as temperature below where the forecasted temperature is, or in the case of a METAR, what the actual temperature is. Very similar presentation for landing analysis, except this time, of course, everything is based on landing. And we have three options that were shown in the chart: zero wind, the planned wind, and a 10-knot tailwind. So, of course, 10-knot tailwind is our worst case scenario because that's as much as we're allowed to do. Zero winds is sort of a nice number that I like to take a peek at if I believe there's going to be a headwind, because of course I know if I can do it at zero winds, I can do it with a headwind. And planned winds is good for the planning performance, but again, we want to do an actual prior to top of descent to see what our actual needs are. So looking at runway 28, we can see that with the planned winds, we're going to need 2,548 feet of runway. That's actual. The factored is 4,255 feet with a maximum allowable weight of 36,063 pounds because we're runway limited. I'd like to draw your attention as well to the red landing impossible. So runway 16 and runway 34 are good examples of that at East Hampton because the runway is simply too short. So there's no wind and temperature and weight combination that allows us to land on that runway. And finally, on the summary page, we have the emergency return. This is essentially, as we talked earlier, for returning right back into Eagle from our departure runway, the parameters that we've set, and we can see what our V approach and VREF is, how much our actual landing distance of runway, actual runway required is, as well as our approach climb gradient and go around N1. As I finish up on the summary page, something I like to do is upper right-hand corner, I press the send to button and I choose to save to a flight's files. And what that allows me to do now, if I go back out of the summary and I back out to the main flight page, we'll see along the top of the screen, we now have a button that says one file. If I press that, then I am given the PDF takeoff and landing summary. So I can retain that for future use or in-flight use if I want to view what my plan numbers were in a PDF format. Pretty handy. Like I say, it's always retained. So it's handy to go back and see what the parameters were for a specific takeoff if there's ever a need. Reiner, anything to add on that?
No, I think that's a great tool because many operators retain their flight records, and having it available this way is part of the paperless world, really.
Yeah, I certainly agree. And like I said, that's what I do for the operation that I have. And it's quite nice to be able to look back, a week, a month, or heck, even a year later and see, what were my parameters that I did that trip last year and how can I do it, this year? Because that question comes up from time to time.
Is there a limit to the number of plans that can be saved? Or
yeah, I know we do have several customers that have files, well into the hundreds, if not thousands. So it's not a limit that I think the typical user should expect to find. So before we move on from the runway analysis topic, I wanted to briefly discuss engine out procedures and sort of behind the scenes view. So all of our EOPs are designed in-house using our own proprietary design software. It's a pretty neat tool that allows us to essentially visualize various departures from airports all around the world. And from there, we're able to create a route that avoids as many obstacles and terrain as possible and actually build into the procedure. What we're looking at on this slide is in the blue, we have the obstacle corridor, which in this case is set up for FAA. We're departing Eagle, runway 25, just as we did earlier. And we're able to visualize our design of the procedure. So we can see what's happening here and making the turns and entering holding, as well as how it relates to the terrain. As we discussed, all of our obstacle departure procedures actually, I should say, as we discussed, all of our EOPs, they follow the AC 120-91A guidance, as well as the equivalent guidelines for ICAO. The caveat here is that you must set which guidelines you are going to do, or which guidelines you require, I should say, for that takeoff. So we will amend sort of on the fly, but it's based on the user's setting. So in this tool that we have, all of our EOP guidelines, such as the path, the obstacles, the one engine and operative climb performance, they're evaluated for multiple aircraft that we actually have in the tool. So we're able to see at design time whether the EOP we're designing is a good procedure or not. From there, all of the EOPs are reviewed by a peer who's able to kind of get their eyes on it and see as well if they like what they see, or in some cases, hey, if we go over here, I think we can depart a little bit heavier. And the designers get that feedback right away. So they're able to see, hey, for these select aircraft that we have built into the tool, this is the impact of the change that you just made. It's a pretty slick tool. It's pretty amazing to use. I've been involved with the creation of the tool as well as the creation of the procedures since the very beginning. And I'm pretty happy to say we're up to around 6,000 procedures now, and truly more are being added every day. A little bit more from my perspective as one of the individuals that, like I say, was involved in the EOP creation and design. Our EOPs are designed with the pilot workload and flyability in mind. So as I mentioned, if a SID or a departure procedure exists, we're going to make all attempts to use that initial path for the reason that the FMS likely already is loaded with that path. So minimal changes in the event that you go one engine and operative, you're able to fly what's already loaded in the FMS. In the event that a SID does not exist from that runway, then we do our best to keep the EOP path and instructions as simple as possible. In the early days of using EOPs, I often came across procedures that were quite complex. They would say, maintain this heading until crossing the 178-degree radial, and then pick up a heading of 200 degrees till 6.8 DME, and turn right to intercept the ABC VOR 123-degree radial. And I think we could all agree, if you just lost an engine, those are pretty complex procedures to fly. The vast majority of the procedures that you receive out of ForeFlight Mobile are going to be RNAV based, which really makes them quite simple to fly. And hopefully, like I say, they even mirror a departure procedure that you've been cleared on. So the transition is quite minimal. We have experienced jet pilots that review and accept or reject these EOP designs for any concerns whatsoever, whether they're flyability, complexity, or maybe they can just be improved upon. I think one thing before I stop discussing EOPs is a couple of months back, I had the opportunity to fly the EOPs off of Eagle in the simulator for the Challenger 650. And I loaded the simulator up to the absolute maximum takeoff weight allowable per the EOP and flew the procedure. And although I am intimately familiar with these procedures and how we design them, I still have to say I was very impressed with how easy and smooth everything flowed. And, the picture out the window, it's not what I would want on a 2-engine takeoff, but I was very happy with it for a 1-engine and operative departure. Before I close up, Reiner, any questions you might have or any comments you'd like to add about EOPs?
No, I like the way this is all integrated, and not that I would look forward to flying one of these procedures. I'm confident that if I had to, it would be pretty reasonable.
Yeah, great. I agree. So thanks a lot. And now back to you, Sam.
Awesome. Thanks, Josh. Before we move on to Q&A here, just a few links that you can follow up on to learn more about what we've talked about today, as well as watch the webinar recording. You can learn more about ForeFlight runway analysis at foreflight.com/RWA. You can also see the full list of supported models on that same page, but you can get there just with this direct link, foreflight.com/RWA-models. You can also register for more upcoming webinars and watch any of our past webinars by visiting foreflight.com/webinars. And this webinar in particular should be up on that page by tomorrow. So just go there and you'll find it embedded on that page so you can watch it again or share it with anyone else you think would like to see it. And finally, you can contact the ForeFlight support team at team@foreflight.com, as well as the ForeFlight sales team at sales@foreflight.com if you have any questions for them about runway analysis or just purchasing ForeFlight in general. So with that, let's move on to some questions. All right, so first up here, there's this question about how RCC values are calculated. And they said, we've seen that using the manual calculations from the QRH gives significantly higher landing distances than what we see in the aircraft FMS. Michael, do you want to take this one?
Yeah, sure. Thanks, Sam. And Reiner, I'm going to pull you in here in a minute or so to provide some perspective. But basically, as mentioned previously by Eric and Alex, we have access to all the performance data from the TechPubs library, and we have incorporated the QRH-based RCC landing distance data. So that's what we have to work with, and that's what's currently in there. Reiner, I believe you might be able to speak a little more towards the FMS functionality on this one. Is that correct?
Yes, the FMS factors function is a pretty conservative set of data, and it covers a pretty wide band of information. And because it is so conservative, it shouldn't be used to compare with the actual specific RCC values for a particular condition. Mostly because the FMS is not itself capable of calculating the RCC codes or the user producing those types of calculations, what's happened is that we provided a table of FMS factors for a range of conditions, and those would be used basically if you had a conservative situation. For example, you're landing on 12,000 foot runway and the conditions are reasonable. It's not a big deal. Throw in your factor that's taken from the factors table into the FMS. That tricks the FMS into providing so-called data for that. But again, it is conservative. And so most likely you won't have any issues landing on that length of runway. If you were dealing with an example like the runway we had today in today's exercise, that's pretty short. You certainly wouldn't want to use the FMS factor in that. You'd want to go to the RCC condition tables and for the particular condition and make that calculation. And you probably have to do some manual entries in the FMS to make that work. Again, the FMS works in ALD based calculations with factors that deals with, landing field length and that's that type of thing. The RCC is a different set of calculations that the FMS cannot do, and the FMS factors table is used to in a conservative way, make the FMS give you some numbers that work, towards that. Again, it's not as accurate nearly as the individual tables are for the various conditions. So if a third-party provider or some other calculating tool was to give you the landing distances based on those calculations, then it's the RCC condition tables that would most approximate those answers. Hope that answers the question.
Yeah, thanks, Reiner and Michael. So next question here, with standard weights, can these be configured by the operator? we have a standard weight for a female flight attendant and a standard weight for a male flight attendant. Alex, do you want to take that one?
Yeah, so within our dispatch product, you can configure standard weights for a couple of different types of passenger and crew types. That includes pilots and cabin attendants, not necessarily male versus female cabin attendants, and also passengers, which are split up into adult, male, female, child, and infant. So you can change that within your dispatch settings to be applied sort of for every flight that's coming through dispatch. And then there's a separate settings page within ForeFlight Mobile, and you can configure I think male, female, and child there, because those are the standard weights that are configurable within when you're starting from the mobile app. So you can change those there. You can also, within the mobile app, if you apply a load to a station, you can add a description to it. And when you do that and close out of that, it sort of makes that load a saved load available for future flights that you're planning. So it's another way of adding a sort of customized saved load with a standard weight.
Great, thanks, Alex. Next up here, can an aircraft be set up for a group of users, or do individual users have to set up their fleet themselves? Do you mind taking that one as well, Alex?
Yeah, no problem. So you can really do it either way. There's a concept of creating sort of an aircraft at the user level within ForeFlight, and then as an administrator on a group account, you can publish that aircraft, which makes that aircraft available to all users on the account. So if you do it that way, you can sort of centrally manage your settings, including the weight and balance profiles and that sort of thing, and make sure that information gets pushed down to other users on that account.
Great. Next question here. The Challenger 600 series aircraft have multiple fuel tanks, each with varying moments. Does the new weight and balance in ForeFlight allow for custom fuel loading of the main, auxiliary, and tail tanks and burn down for the Challenger 606 and 650? So Josh, since you are a pilot of these aircraft, do you want to go ahead and answer that question?
Yeah, sure. We are very aware of the multiple fuel tanks in the Challenger, of course. Like you said, Sam, I fly one. And we do absolutely support the multiple fuel tank setup, as well as fuel burn sequencing is correct in the weight and balance. When you compute a weight and balance using ForeFlight Mobile, you'll actually be able to see the weight and balance plot where the fuel initially transfers from the tail to the aux, and then the tail depletes and the aux feeds the mains and what have you. You can see that as you move as the CG moves. So it's something that's supported for sure in weight and balance.
Thanks, Josh. Next up, this is another good one for you. Can weight and balance be used without an internet connection?
Yeah, absolutely. Weight and balance is fully usable both online and offline. That functionality is built into the app and does not require any connectivity.
Awesome. Next up, are there engine out procedures all ready for international mountainous airports? And they provided an example of Tegucigalpa in Honduras. So Josh or Michael, I think either of you could address this.
So we do have procedures that are available, both domestic and internationally. EOPs are continuing to be developed worldwide. So if you happen to come across one that we don't yet support, by all means, send it over to the team at foreflight.com address, and we'll be sure to add it to our queue and get a procedure developed as able.
All right, next question here. Is this as legally binding, and this is referring to runway analysis, is this as legally binding as TERPS or PANOPS? I know APG is approved, air quotes there. Is this equally recognized? Thanks. Josh, do you think you could handle that one as well?
Yeah, so I'll talk a little bit about that. And so TERPS or PANOPS in comparison to our runway analysis are a little bit of apples and oranges, because the TERPS and PANOPS are all engine procedures versus runway analysis is an engine and operative procedure. So said another way, the PANSOPs and TERPs are used in normal conditions. Runway analysis is used in abnormal or emergency conditions. So one engine inoperative after losing an engine at some point after V1, so you've continued the takeoff. So that's why I say they're a little bit apples and oranges. The procedures are that we developed, the runway analysis procedures are, in my experience, have been approved, not approved, but accepted by regulatory authorities. I'm not aware of any actual approval that regulatory authorities give other than the more of acceptance. And they're accepted with the understanding of they're derived from AFM data. So perhaps either Michael or Reiner have anything to add to that?
I don't.
Yeah, it's Reiner. I don't have anything else to add to that. Basically, you're using the aircraft data and you're working with the parameters associated with the safety factors required. So I think it's all valid. As far as approvals go, I don't think that particularly exists, because there'd have to be an approval for each calculation done if that were to be valid.
Yeah, absolutely. And like you say, Reiner, the numbers that we come up with, the performance that we derive is AFM based. And in addition, you're using our terrain and obstacle database on top of any custom terrain or custom obstacles that you add. So it's AFM data with maybe a little bit of a finer point pencil, so to speak.
All right, sounds good. With that, I think we'll go ahead and wrap this webinar up. Thank you everyone for attending, and thank you everyone from both ForeFlight and Bombardier for helping out with this webinar. I think this was a really great and informative presentation of some of these new capabilities we have for Bombardier pilots. So just again, referring to these links on the current slide, you can see which Bombardier aircraft we support at foreflight.com/RWA-models, and you can learn more about that feature in general on the rest of that page. Starting tomorrow, you'll be able to watch a recording of this webinar at foreflight.com/webinars, and anytime we have new webinars available for you to register for, you can find them there. And of course, if you have any questions about ForeFlight, just email team@foreflight.com. And if you're interested in getting set up with a trial of ForeFlight runway analysis and weight and balance, or many other types of ForeFlight capabilities, just email sales@foreflight.com, and they will be able to start that conversation and get you set up with something. So thanks again, everyone, for helping out and attending, and we'll see you on the next webinar.